Hi, we're using this GeoGebra applet, which I will put in the notes of this video. We are going to explore some of the properties of polynomials. We're going to do a quartic, jump down to a cubic, a quadratic, and then a linear. Okay, so these are all going to be on the function y is equal to ax to the fourth plus bx cubed plus cx squared plus dx plus e. At the moment, we've got y is equal to x to the fourth minus 3x squared minus 4. These two are 0. We can move these sliders here to get different values. So at this particular point, for an order 4, a quartic equation, we have 4 real roots, some of which could be repeated, or all of them could be repeated, 2 real roots and 2 complex roots, or 4 complex roots. So the situation we got at the moment is 2 real roots and 2 complex roots. These are the complex ones marked on sort of an Argand diagram using these axes. And we've got 2 real roots at minus 2 and 2. So if we now move the b so that it is minus 4, C that it's 6, D is minus 4, and E is 1, plus 1. Okay, what we've got here we need to put E onto 1. Okay, so what we've got here is we've only just got one root. So we've got that root has been repeated 3 more times. We've got that root and itself repeated 3 more times. So we've got the situation where we've got 4 real roots. Okay, let's now make A 1, B 0, and C 0. No, C is going to be minus 5, sorry. And D is going to be 0. And 4 for E. Okay, this is a situation where we've got 4 real roots at minus 2, minus 1, 1, and 2. We put the 1 in the right place. Okay, there we go. And then if we now look at this one, so A is 1, C is minus 2, and D 0 and E is going to be plus 1. Okay, here we have 2 repeated roots. We've got 4 real roots, but 2 of them, this one's repeated and this one's repeated because it just touched the axis. If we now change the E to plus 5, or plus 4, that would do. Okay, what we've got here is we've got complex roots. Okay, there's no, the curve doesn't cut it. These complex roots occur in what's known as conjugate pairs. All right, these have been plotted onto an Argand diagram. And finally, for the cortex, if we we'll just leave it like that. That'll give us 4 complex roots. Okay. Right, so we've sort of looked at all these sort of different cases there. Let's now go down to a cubic. So cubic, A will have to be equal to 0, and B will have to have some value. So for cubic, we're going to have 3 real roots, some or all could be repeated, or 1 real root and 2 complex roots. So in the first case, we're going to have B equal to 1. So there's no x fourth term in a cubic. C is minus 6. And D is 12, and E is minus 8. Okay, so here we have just one root which has been repeated 3 times, okay? which is here. So it's still got 3 real roots, but all of them have been repeated. They're all repeated. And now we're going to make c minus 3. D we're going to make 0. And E we're going to make plus 4. Okay, so again we've got 3 distinct roots. Maybe if we make it something a bit better than that. Let's try minus 2. D is minus 1. And this is 2. There we go, that got something much better there. So here we've got 3 real roots. Okay, so in this one, sorry, I've just moved it along a bit. We've got A is 1, B is minus 3, and E is 4. The others are all on 0. What we've got here is we've got 1 root here, and this is the other root here, which has been it's been repeated. Okay, so this is still the case of 3 real roots. And let's just do the last case. So we've got 1 minus 2 minus 3 and 10. Okay, oh, that's on 12. Let's do 10. Gives nicer values. Okay, so what we've got here is we've got the case of 1 real root and then 2 complex roots here. Notice again they occur in conjugate pairs, which is quite important for this topic. Right, on to a quadratic. So quadratic is going to be a bit easier for us to do. Okay, so here we've got a quadratic, minus 2x squared minus 3x plus 10. Okay, and what we can see here is that we have 2 real roots. Okay, so let's now do this one. Let's make C 1 plus 1 and minus 2 and 1. Okay, so here we've got x squared minus 2x plus 1, and here we've got 2 real roots but repeated. Okay, and if I just raise E up, what we get here is we get complex roots here. Again, they occur in conjugate pairs. You can see the curve doesn't cut the axes. And then finally, if we make C equal to 0, we get a straight line, a linear equation, order 1. Okay, here the solution's at 3. We can change the value of D for other values if you like, get fractions if you want. You've got to be careful if E is equal to 0, because if E is equal to, if we get this situation, of course we're not going to get any solutions, because the solution will just be the value, that would be y is equal to 4, so there's no equation there to solve. And also if we get a vertical line, that's a bit more difficult as well, yeah. Okay, so what we've looked at here then is a quartic, a cubic, a quadratic, and a linear equation, looking at the types of solutions we've got. This GeoGebra applet, the link I will put in the notes of the video. I hope you've understood, and I hope you've enjoyed the video, and I thank you very much for watching.